So what is the chemical kinetics? Remember, chemical kinetics is a branch of science where you are going to study about the reaction rate, at what speed the entire reactions which is happening. A change in concentration of reactant divided by product at any time. It may be either reactant, either it may be a product with a unit type. So that the concentration of the reactant is started decreasing as the time increasing. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, let us discuss the new unit called Chemical Kinetics. So before going to discuss with this unit, let's see the weightage of this unit. So from this unit, we can easily expect 8 mark. There is a 1 mark question and 1 2 mark question, and there is a 1 5 mark question. And totally we can expect how much? 8 marks from this long unit. Okay, and it is one of the easiest unit where you can easily get 8 on 8. So before going to discuss with this unit, let's see what we are going to discuss in this unit. So in this session, we are going to discuss with the introductory part of this unit, and we are going to understand with the rate of chemical reaction, then average rate of a reaction and instantaneous rate of a reaction, and the factors that affects the reaction rate and the dependence of rate on the concentration, and also we talk about the rate constant of a reaction and the characteristics of the rate constant. So before going to deal with all these things, let's see how the entire unit which has been classified. Okay, so in the chemical kinetics, first we will understand what is a reaction rate. Under that, we have a initial rate, average rate and the instantaneous rate. Only these two you are going to understand in this unit. Okay. Again, the factors which affecting the reaction rate, there are 4 different factors will be there. That is a concentration, temperature, catalyst and the surface area. How does all these factors which affects on the reaction rate also we are going to discuss. Later, we are going to understand more about the rate law. In that, we are going to understand what is the order of the reaction, then molecularity of a reaction and the rate constant. Okay. In the rate constant, again, we are going to discuss with the first order reaction, second order reaction and the zero order reaction. And finally, in the rate constant, we are also going to discuss with the collision theory, and also we are going to discuss with the temperature dependence of the rate, and also we are going to discuss with the order of the reaction. This is how I made the mind mapping about this unit. Hope you all understood with this mind mapping. Now, let us understand what is a chemical kinetics first. Okay. The branch of chemistry which deals with the study of reaction rates and their mechanisms, they are known as chemical kinetics. What is the chemical kinetics? It is a branch of the chemistry that deals with the study of reaction rate. In what rate the reactions will be taking place, in what speed the entire reactions will be taking place, that studies will be involved in the chemical kinetics. Not only we are going to understand the reaction rate, we are also going to understand the factors that influences the rate of the reaction. You know, based on the speed of the reaction, there are 3 different reactions will be there. The first one is slow reaction. For example, in case of rusting of iron, if you keep the iron nail for the longer time, say about 2 months or the 3 months, it takes a longer time in order to convert it into rust. It takes 2 to 3 months. It is a slow reaction. Is it right? Similarly, there is a fast reaction. For example, in your first PUC, you would have seen that while doing the salt analysis, something you are going to mix with your salt and you will get a precipitate. Is it right? That is a fast and immediate reactions you will obtain. Similarly, if you keep the ice cubes outside, it will melt and it will changes into water. These are the sudden reactions which is also happening in our surrounding that comes under the fast reaction. And there are certain reactions which is not too fast or not too slow. They are known as moderate reaction. For example, the photosynthesis, is the best example for this, and the spoilage of the food. For the spoilage of the food, the spoilage of the vegetable, if you take, it takes around 1 week. So, it is a moderate reaction, not too fast, not too slow. Similarly, the spoilage of fruits and spoilage of bakery item, and you can take the photosynthesis also. So, all these are the 3 types of the reaction which is mainly depends upon the speed of the reaction. So, what is the chemical kinetics? Remember, chemical kinetics is a branch of science where you are going to study about the reaction rate, at what speed the entire reactions which is happening. Not only you are going to study about the reaction rate, you are also going to understand the factors which influences the reaction rate, and also there are 3 types of the reactions will be there based upon the speed of the reaction. One is fast reaction, slow reaction and moderate reaction. One example I have listed on the slide and hope you all understood. Next comes to the rate of a chemical reaction. Now let us understand what is a rate of a chemical reaction. The rate of a chemical reaction is defined as change in molar concentration of any of the reactant or any of the product per unit time. So, what is a rate of the reaction? Rate of the reaction is nothing but a concentration change, or you can say that it is a molar concentration of the reactant divided by molar concentration of the product. Is it right? Or you can write concentration change. Concentration change divided by time. Divided by time is said to be rate. So, what is the rate? Rate is nothing but a concentration change divided by time, or you can easily define it as a molar concentration of the reactant divided by product in the particular time is said to be rate of the reaction. And there are 2 types of the rate of the reactions will be there. The first one is average rate of a reaction and instantaneous rate of the reaction. So, remember, now you have understood that what is the rate of the reaction. Always the rate of the reactions can be obtained by changing concentration of the reactant and the product divided by time. And there are 2 types of the rate of the reaction. The first one is average rate of the reaction and second one is instantaneous rate of the reaction. First, we will understand what is a average rate of the reaction. So, average rate of the reaction can be defined as it is a change in concentration of any of the reactant or any of the product per unit time. So, it is nothing but a change in concentration of reactant divided by product at any time. It may be either reactant, either it may be a product with a unit time. Let us consider a reaction where R is giving rise to P, or I consider R is a reactant and P is a product. How to express in terms of average rate reaction? Let us see now. 1 mole of the reactant R produces 1 mole of the product. So, the molar concentration of the reactant 1 and the molar concentration of the product 1 are the concentration of the reactant and the product respectively. And also after the time changes at the time T1, the concentration of the reactant and the product is also get changed and it will become R2 and P2. Why it become R2 and P2? Because at the time T1, the concentration of the reactant and the concentration of the product will get changed so that it can be denoted as delta T. Delta T is nothing but a change in temperature. The change in temperature can be obtained by T2 minus T1. So what is a T1 here? We know that T1 is nothing but a concentration of the reactant and the concentration of the product. Is it right? Similarly, we know that T2 is nothing but a concentration of the reactant, concentration of the product. I want to find out the differences between the temperature T1 and T2 and that is given by delta T. Okay, delta T is equal to T2 minus T1. First I'll write for the reactant. So if I write for only the reactant, it is obtained by R2 minus R1. Why does R2 minus R1? Greater the concentration of the reactant to minus smaller the reactant concentration. So it will become the change in molar concentration of the reactant is obtained by R2 minus R1. Similarly, the change in product is obtained by P2 minus P1, where you can also write it as delta R, that is change in reactant is obtained by molar concentration of the reactant, and similarly for the change in product is obtained by molar concentration of the product P2 and molar concentration of the product P1. This is how we can easily understand that how the average rate of the reaction can be obtained. So first understand average rate of the reaction, it is nothing but a change in concentration of the reactant or change in concentration of the product with the unit time. For example, I will consider the reaction of reactant which is give rise to the product. Here, 1 mole of the reactant is giving rise to the 1 mole of the product. Now, if I want to express this equation in terms of average rate equation, first I will consider at a time T1. The concentration of the reactant is 1. Similarly, the concentration of the product is 1. At a time 2, the concentration of the reactant and the product again it is changed. Is it no? Yes. So that is why molar concentration of the R and molar concentration of the product is changes from 1 to 2. Okay. Then the difference between these two time is obtained by delta T and it is given by T2 minus T1. This is how we will obtain the equation, and finally we can also express in average rate equation or the average rate reaction, that is the rate of disappearance of R. Why it is disappearance of R? We know that R is a reactant. Is it right? This is a reactant. And we know that this is a product. Imagine at a time 0, the concentration of the reactant is 10 and the product is not formed, so it is 0. Again at a time T1, okay, the concentration of the reactant is 5 and the concentration of the product is 5. Again at a time T2, we can say the concentration of the reactant is reduced to 2 and this will be increased to 7. So here I have assumed the values of the time, reactant and the product. By this we can clearly understand that at a time 0, the concentration of the reactant is same. It is not forming a product only, so that entire concentration of the reactant will be keep as such. So that is why I will consider as a 10. But at a time 2, the reactant is giving rise to the product, so that the concentration of the reactant is started decreasing as the time increasing. So that is why I have written the rate of disappearance of R. What is R here? Reactant. As the reactant is disappearing, which increases that the time is passing and the reactants are giving rise to the product. In such cases, what happened? The concentration of the reactant will be started decreasing. So that it is obtained by decreasing in the concentration of the R divided by time taken. So the decreasing in the concentration of the R, that can also be written as delta R divided by delta T. Remember, it is minus delta into molar concentration of the R divided by delta T. Why is it so? Because during the chemical reaction, the reactant is forming a product and the concentration of the reactant is started decreasing when it is forming a product. Is it right? So that it will be in the negative form. Similarly, I can express it for the product also. How to write? The rate of increasing or the appearance of the product. We know that R is giving rise to product. So that concentration of the product as the reaction is increases, the formation of the product is also get increases. So the rate of appearance of the product is given by increasing in the concentration of the product divided by time taken, which is equal to delta into concentration of the product divided by delta T. And overall, we can define it as rate is equal to concentration change divided by time taken. And this is how, we can easily understand that how they will do the average rate calculation by taking reactant is giving rise to the product. Hope you all understood with the average rate equation. Similarly, you can take the example of A plus B give rise to C plus D. In this above equation, we can easily understand that how to write the average rate reaction. So the average rate reaction is obtained by, we know that these two are the reactant and these two are the product. Reactant and these two are the product. We know that as a time passes, the reactant concentration will be started decreasing and the small a, small b, small c, small d are the stoichiometric coefficient. Okay. Then the average rate reaction can be written as 1 divided by A, because this is a stoichiometric coefficient, and since we are talking about the reactant, it will be in the minus. 1 divided by A into delta into molar concentration of the A divided by delta T. Or if you wanted to express with the other reactant for the B, how to write? Which is equal to 1 divided by B minus it is also into delta B divided by delta into concentration of the reactant B divided by delta T. Suppose if you wanted to express the concentration of the product, how to write? We know that it always presenting a plus sign. So 1 divided by C into delta into concentration of the C divided by delta T, which is equal to 1 by D into delta into concentration of the D divided by delta T. This is how, if you consider the any reaction, we can write the average rate equation. Here again I have listed out the another example where 2 HI, that is hydrogen iodide, it forming hydrogen and iodide respectively. How to write the rate of the average rate of the reaction? The average rate of the reaction is obtained by 1 divided by minus. Why does 1 divided by minus? Because it is a reactant. Is it right? And 2 are the stoichiometric coefficient. So it is minus 1 by 2 delta into concentration of the HI divided by delta T, which is equal to delta into concentration of the H2 divided by delta T, which is also equal to the concentration of I divided by delta T. Okay, this is how we can easily understand that how to write the average rate of the reaction. Hope you all understood now. Now let us understand what is an instantaneous rate of the reaction. Now we have understood that what is the rate of reaction and how to write the average rate of the reaction also we have understood. Now we are going to understand more about the instantaneous rate of the reaction. So in the instantaneous rate of the reaction, it is a rate change of the concentration of any reactant or the product at a particular instant of time. At what time, the concentration of the reactant and the concentration of the product will be get changes, that particular time or that particular instant is referred as an instantaneous rate of the reaction. So it can be obtained by the R instantaneous, that is the rate of the reaction at instantaneous process, is equal to minus D into the concentration of the reactant divided by delta dt. What is that dt and d? Here d and dt are nothing but a change in concentration of the time and the concentration of the product and the reactant respectively. Okay. So, is equal to d into P divided by dt. So, for the above reaction, suppose if I consider any reaction like A plus B give this to C and C plus D and D. In this reaction, how to write the instantaneous reaction? Let us see now. We know that the small a, small b, small c and small d are the stoichiometric coefficient. So that delta A into D into concentration of the A divided by delta T, which is equal to minus 1 by B into concentration of B divided by delta T, which is equal to 1 by C into D into concentration of the C divided by dt, which is equal to 1 by D into concentration of the D divided by dt. Remember, for the reactant, these two are the reactant. We have written the instantaneous reaction and these two are the product. We know that we will explain the product in the plus sign and the reactant in the minus sign. Understood? And always remember, in case of instantaneous reaction, what is the change in concentration of the reactant or the product at a particular instant of time we are referring. That is why it is named as instantaneous rate of the reaction. And units for this rate of the reactions are mole per liter per second. How to write this? I will explain you. We know that rate is equal to concentration changes divided by time taken, right? Time taken. We know that always the concentration changes is nothing but a concentration of the reactant or the concentration of the product. We know that the concentration of the reactant or the product, we always represented like this in the square bracket. Is it right? So, it is nothing but a concentration of the reactant and the concentration of the product. So, it will be mole per liter, and we know that time will be expressed in a second, per second. This is how, we will express a unit of the rate of the reaction. Hope you all understood that why I have taken the mole for the concentration and also for the liter, because the concentration of the reactant and the product should be expressed in a dm cube or in the liters. Okay. Next we will understand by drawing the graph of instantaneous and the average rate of the reaction. To explain this graph, I will consider the rate of the reaction at a time 0, concentration of the reactant and the product at a time 0, the concentration of the product must be 0 and this one will be 0. Again at a 2, the concentration will be 8 and this will be 2. At a time 5, the concentration will be remain same, and at a time 8, it will be completely changes into 2 and 8. I'll consider the concentration of the reactant in the product in this way to explain the instantaneous and the average rate of the reaction. Okay. So first we will draw a graph by considering the concentration of the reactant and the time respectively. First I'll consider only for the reactant. If I plot the concentration of the reactant divided by versus time, okay, what will be the graph? We all know that always when the concentration of the reactant during the chemical processes, it will be start decreasing, whereas the concentration of the product during the chemical reaction, it will be increases. That is why we always refer the reactant in the negative form, whereas the product in the positive form. Is it right? So that is why I have draw the graph of a concentration of the reactant on the y-axis and the time on the x-axis. Suppose how to determine the average rate of the reaction. The average rate of the reaction is obtained by minus delta into concentration of the reactant divided by change in temperature, which is equal to C2 minus C1 divided by T2 minus T1. How does it obtain? We know that the concentration of the reactant at a time 0, it will be constant. As the time passes, the concentration of the reactant will be start decreasing. Why it is decreasing? Because the reactant is forming a product. That is why the concentration of the reactant will be constant. Is it right? But as the time increases or as the time passes, the concentration of the reactant will be decreases. That is why you will get a negative slope. Understood? Here, consider at a time T1, the concentration of the reactant is, the differences between 0 with the T1 is C1. Okay. At a time 2, the concentration of the reactant is at delta T, which is given by at the C2 by taking the differences between with the first and the last. So this is how we can easily determine the average rate of the reaction by considering C2 minus C1. C2 minus C1 is nothing but a concentration of the reactant at a time 0 to 2. That is from T2 to T1. At what time the concentration of the reactant is get altered, that is get indicated by C2 minus C1. Similarly, we can express the instantaneous rate of the reaction for the reactant only. That is given by the R instantaneous is equal to minus D into concentration of the R divided by dt, which is equal to negative slope. Why it is negative slope? We know that at a time 5 you can take the reactant is and the product which is completely changes into product. The reactant is completely changes into product. Is it right? At a particular time, the change in concentration of the reactant or the product at a particular time is known as instantaneous rate of the reaction. Here, at a time t, you can see at a time t, the reactant concentration will be completely equal to the product. That is why I have drawn the slope so that I can get the negative slope. Why I will get a negative slope? Only because this is a reactant and we have to express in a negative form. This is how only for the reactants, we can express in an instantaneous rate of reaction, and only for the reactant we can also express in an average rate of the reaction. Now let us see with the product. Again, I am plotting the concentration of the product versus time. So the time is on the x-axis and the concentration is on the y-axis. We all know that at a time 0, the concentration of the product is 0. The concentration of the product is 0. Is it right? Yes. As the time passes, you can see in this value, the concentration of the product will be increases. It will be started increases. That is why you will get the positive curve. And by this, we can easily write the average rate of the reaction. Average rate of the reaction is obtained by the change in product divided by change in time. That is obtained by, so here the average rate of the reaction is obtained by plus change in concentration of the product divided by change in time. So that is obtained by, as the time passes, at a particular T1, time 1 you can say, the concentration of the product will be obtained at a concentration C1. Similarly, at a time 2, the concentration of the product will be again increases and you will get the concentration at C2. So, it has change in concentration. It is obtained by C2 minus C1 divided by change in time, that is obtained by T2 minus T1. This is only for product in terms of average rate of the reaction. Similarly, if you write for the instantaneous rate of the reaction, we all know that instantaneous rate of the reaction will be happen at a particular instant where the reactant is completely equal to the product. Is it right? At a particular time t, we can say it, the instantaneous rate of the reaction is obtained by plotting a slope where the concentration of the product divided by time which is equal to slope, and this is a positive slope we will get it. This is how we can easily draw the graph of concentration versus time for the instantaneous reaction as well as for the average rate of the reaction. Next, we'll understand what are the factors which affects on the reaction rate. So, already I told you that the factors which affects on the reaction rate is also very important for the examination point of view. For the 2 marks, they can ask. What are all the factors which affect? The first one is the nature of the reactant. What kind of reactant you are taking, whether it is organic, whether it is ionic, that matters a lot. So, the reactants involving the polar or the ionic substances are quite fast, whereas those are involved in the covalent compound are much slower. This is how, if you select the reactant for the reactions to happen, that must be whether it undergo a fast reaction, slow reactions or the moderate reaction, we need to understand first. Later only we can select it for the reactions to happen. Suppose if the organic compounds are there or the ionic compounds are there, their reactions will be very fast. Suppose if you consider the covalent compounds, the reactions are very slow. This is how the nature of the reactant which also affects on the reaction rate. Then comes to the concentration of the reactant. It is very important. In general, the rate of the reaction will be increases on increasing the concentration of the reactant due to the increasing in the probability of molecular collision. As the concentration of the reactant is increases, the rate of the reaction which is also get increases due to the more collision of the reactant molecule. Temperature. The rate of the reaction is usually increased with increasing the temperature. For the most of the homogeneous reaction, the rate will be become doubled for the 100 rise in temperature. The temperature which also play a very important role in rate of the reaction. Then comes to the presence of catalyst. We all know that the catalyst are the substances either increase or decreases the rate of the reaction. Is it right? So, the presence of the catalysts which also provide the alternative path of a lower energy barrier or thus enables a larger number of reactant molecules to cross through it and take part in the reaction. Therefore, the catalyst which also increases the rate of the reaction. This is how the catalyst, temperature, concentration of the reactant and the nature of the reactant which mainly affects on the rate of the reaction. Next we will see the dependence of rate of the reaction on the concentration. Now I will consider only the concentration. How does it depends on the rate of the reaction? Let us understand now. So first, for that we need to understand what is a rate law. The representation of rate of the reaction in terms of concentration of the reactant is known as rate law, and it is also known as rate equation or the rate expression. So what is the rate law? It is a representation of rate of the reaction in terms of concentration of the reactant is known as rate law or the rate equation or the rate expression. So let us see how to derive this. What is the rate expression or the rate constant? The expression in which the reaction rate is given in terms of molar concentration of the reactant with each term raises to the some power with may or may not the same as a stoichiometric coefficient of reacting species in a balanced chemical equation. Suppose I will consider the equation where A plus B leads to the C plus D. Here small a, small b, small c and small d are the stoichiometric coefficient. Why we will write the stoichiometric coefficient? In order to balance the chemical reaction, right? So the rate expression can be determined as or written as rate is equal to, rate is directly proportional to the concentration of the A into concentration of the B. Here we won't write the stoichiometry as A plus B. Instead of that we will write X and Y. Here the X and Y, they are nothing but a stoichiometric coefficient, but they are exponents. The exponent X and Y may or may not be equal to the stoichiometric coefficient of the reactant, and above equation can be written as rate is equal to the concentration of A, X into concentration of the B, Y. And here the K is represented as a proportionality constant. You can write like this, rate is equal to K into concentration of the only the reactant we are taking and the concentration of the B. Is it right? Here the K represents the proportionality constant which is also known as rate constant. Equation 1 which relates the rate of the reaction to the concentration of the reaction, hence this is also known as rate law. Already we have understood that in the rate law it always determines the concentration of the reactant. So that can also be written as minus D into concentration of the reactant divided by dt, which is equal to K into concentration of the A, F and concentration of the B. This form of writing the reaction or the rate equation which is also known as differential rate equation, because we are expressing this rate reaction in terms of another mathematical form. Hence this is known as differential rate equation. Remember the rate law which always describe the concentration of the reactant. That is why it is minus D into concentration of R. Hope you all understood with how the concentration which also depends upon the rate of the reaction. Next we will see the rate constant, that is K of a reaction. The rate constant is equal to the rate of reaction when the product of a molar concentration of the reactant is unity. Remember the K, that is a proportionality constant which is also known as rate constant, which is always equal to unity only when the concentration of the product, molar concentration of the product is equal to unity. How to write this? For example, Let us consider the reaction 2NO give rise to O2 plus 2NO2. Here, there are 2 NO are there. So, how to write the rate equation? We know that the rate equation can be written as rate is equal to NO into 2, where the X is 2 and into O2. This is for the reactant, and differential forms of the rate expression is given by minus D into R divided by dt, which is equal to K into NO into O2. Why it is O2? Because the reactant which is forming product, then only the proportionality constant will be equal to unity. The rate constant is equal to the rate of the reaction when the product of molar concentration of the reactant is unity, then only it will become 1. Next, we will understand the characteristics of the K, that is the rate constant. That is obtained by, it is a measure of the rate of the reaction. Higher the values of the K, greater will be the rate of the reaction. If the values of the K is increased, obviously the rate of the reaction is also get increased. For a particular reaction, definite values of the K at a particular temperature, the values of the rate constant is increases with increasing in temperature. As the temperature increases, the rate constant is also get increases, and it does not depends upon the initial concentration of the reactant. Suppose at the time 0, the concentration of the reactant will be 10. So, it does not depends upon the initial concentration of the reactant, because the reactant is not forming a product. Is it right? That is why at the initial concentration of the reactant, it will be equal to 0 only when the rate is not dependent on the concentration of the reactant. Then, unity, its units are depends upon the overall order of the reaction. So, more about this order of the reaction, we are going to understand in the next session. So, hope you all understood with the today's session. We have learnt what is the rate equation, how to write the average rate of the reaction, and how to write the instantaneous rate of the reaction also we have understood, and the factors which are affecting the rate of the reaction we have understood, dependence upon the concentration on the rate equation we have understood, then the rate equation, rate law, and also we have learnt about the characteristics of the rate constant. In the next class, we are going to learn more about the order of the reaction. So, by this, I like to say that what are all the topic which I covered in this session, it is very important for the examination point of view. Have a look on it and try to work out. We'll meet you in the next session. Till that, take care and be safe. Thank you.